All right, so far this year we have done, we did a little bit of average rate of change, right? So average rate of change, we're just finding the slope between two separate points on a graph. And then right after that, we said, all right, well, let's write an equation of some secant lines. So we did a little bit of writing equations of those. Then we just jumped onto, well, let's stay with these same curves, whatever that curve may be. And now let's find what is the instantaneous slope. So what is the slope of the line going through that one point? Okay, it's only hitting the graph at that one point, and that is known as a tangent line. All right, this here is a tangent line just hitting the graph at that one point. All right, so that instantaneous slope is going to have the same slope as the slope of the tangent line. All right, and now we're going to learn how can we write the equations of those tangent lines today. So we are just going to do one example here, and we are writing the equation of the line tangent to f of x equals negative 3x squared plus 8x minus 4 at x equals 1. Okay, so we want a tangent to f of x at x equals 1. Well, when we were working with secant lines, we were writing equations in point-slope form. We want to keep using that point-slope form, which we know is y minus y1 equals mx minus x1. All right, so what do we need in order to write the equation of this line, of this tangent line? We need a point, and we need a slope. So let's find each of these and stay organized. So do I have a point? Well, I've got half a point, right? I know it's at x equals 1. Well, how can I find the y value of that point? Let's just plug it in, right? That point is going to be 1 comma f of 1. And I'm actually going to take this slope work and move it over. I'll get there. All right, so if I want to take what is f of 1, that is going to give me negative 3 times 1 plus 8 times 1 minus 4. I get negative 3 plus 8 is 5 minus 4 is 1. So, all right, f of 1 is 1. It just kind of turned out that way, but we'll take it. So we know we're going through the point 1 comma 1. And then the question is, well, wait, what's the slope? Okay, what's the slope of that tangent line? Well, the slope of that tangent line is going to be the same as the instantaneous slope at that point. Well, how can I find the instantaneous slope? I'm just going to take the derivative. All right, take the derivative of f of x. Using the power rule, we should get 2 times negative 3 is negative 6x plus 8. So this negative 6x plus 8 gives me the slope at any x value. Well, if I want to find it at x equals negative 1, or x equals positive 1, excuse me, let's plug in positive 1. So when I plug in 1 to find the slope, which I'll label as m, get negative 6 times 1 plus 8, giving me negative 6 plus 8 is 2. So I get a slope of 2, and it goes through the point 1 comma 1. So the equation of my line using point-slope form now is going to be y minus y1, which is y minus 1, equals 2 times x minus x1, which x1 is also just 1. And boom. That is that. That is the equation of my line tangent to f of x at x equals 1. Hope this video helped. Good luck with the homework.